Hello and welcome back to Machine Learning. I'm Jovita Christie, and in this video, we are going to see some applications of machine learning and some tools and technologies that can be used for machine learning. So let's begin. Wherever you have substantial amount of past data, you can use machine learning to gain insight into the data and to generate some predictions. And even though machine learning is adapted in several forms of every business domain, we are going to cover in this video only three main domains, just so that you get some idea about what types of actions can be done using machine learning. So the first domain we are going to talk about is banking and finance. In the banking industry, fraudulent transactions, especially the ones related to credit cards, are extremely prevalent. Okay. Most of the time people are getting credit cards, maybe they are not paying up afterwards. So those are fraudulent transactions and they happen quite often. So most of the times banks have to understand that. And since the volumes as well as velocity of the transactions are extremely high, high performance machine learning solutions are implemented by almost all leading banks across the globe. It is not possible for human beings to manually go through such data because there are millions of transactions happening at the same time at different times around the world. And the banks cannot manually keep track of all this. So they need some high performance machine learning solution, which is used all the time. The models work on a real-time basis. That is, the fraudulent transactions are spotted and prevented right at the time of occurrence. Okay, so it is real time. It has to be real time. The person should not be able to get away with such transactions. And this can help in avoiding a lot of operational hassles in settling the disputes that customers will otherwise raise against those fraudulent transactions. So because they are caught red-handed and in real time, it's easier to settle such disputes. Customers of a bank are often offered lucrative proposals by other competitor banks. And proposals are like higher bank interest, lower processing charge of loans, zero balance saving accounts, no overdraft penalty, etc. All these are often offered to customers with the intent that the customer would switch over to that competitor bank. And also sometimes customers get demotivated by the poor quality of services of the banks and shift to competitor banks. Okay, so they sometimes shift because other banks are giving more lucrative offers, or they sometimes shift because their current bank is not good enough. Now, machine learning can help in preventing or at least reducing this type of a customer churn. Customer churn is where customers leave one bank and go to the other. Both descriptive and predictive learning can be applied for reducing customer churn. So remember, predictive learning is supervised, descriptive is unsupervised. And you can apply both in order to avoid such things. If you use descriptive learning, the specific pockets of problem, that is a specific bank or zone or type of offering like a car loan, all those things can be spotted where the maximum churn is happening. So you can spot these things using supervised learning. And quite obviously, these are troubled areas where further investigation needs to be done to find and fix the root cause. Using predictive learning, the set of vulnerable customers who may leave the bank very soon can be identified. Okay. And proper action can be taken so that those customers do not leave and they stay. So if you already know these customers are going to leave because of these reasons, you could also, sort of up your offer so that they can stay, that you can try to convince them to stay. The next area where machine learning is widely used is insurance. It is extremely data sensitive, and so machine learning is extensively used in insurance industry. And the two major areas where it is used are risk prediction during new customer onboarding and claims management. During new customer onboarding, based on the past information about that person, you can create a risk profile of that person so that you know how risky it is to give insurance to such a person, right? So if you're giving an maybe car insurance, then how risky is it? How likely is the person to meet with an accident based on the past accidents that have happened? Based on the quantum of risk predicted, the quote is generated for the prospective customer. So based on whatever the risk was there previously, based on that, a quote is generated for the customer. When a customer claim comes for settlement, past information related to historic claims, along with the adjuster notes, are considered to predict whether there is any possibility of the claim to be fraudulent. So sometimes people get, home insurance, car insurance. Sometimes they even get insurance for themselves so that when they die or if they fall sick, there is health insurance. So whenever a person has to undergo some major surgery and has to claim that insurance, at that time, machine learning is used to check the validity of such a claim. Other than the past information related to the specific customer, information related to similar customers, that is, the people belonging to same geographical location, age group, ethnic group, etc., they are also considered to formulate the model. The third domain is healthcare, where we use a lot of wearable device and that generates a lot of data, which is a rich source for applying machine learning and predict health conditions of the person in real time, which is nowadays quite popular. In case there is some health issue which is predicted by the learning model, then immediately the person is alerted. So the person can take some preventive action. For example, there's a abnormal heart rate or something of that sort, and the person can be alerted about that. In case of some extreme problem, doctors or healthcare providers who are in the vicinity, nearby areas, they can also be alerted if a person, say, is going through a heart attack and the wearable device detects it, then a nearby doctor or someone can also be informed so that the person can get immediate medical attention. Suppose an elderly person goes for a morning walk in a park close to his house, and then while walking, his blood pressure shoots up beyond a certain limit, and that is tracked by the wearable device. Then that data is sent to a remote server, and a machine learning algorithm is constantly analyzing that stream of data which is coming. And also it has some history about the person, like the person's age group, and it also has history of other people in the same age group having the same problem. So it's going to predict some fatality unless immediate action is taken. So that means the machine will immediately predict that this person is probably going through some fatal situation right now. And so it can generate an alert that is sent to the person so that the person can immediately stop walking, take a rest, okay, or also send a notification to doctors or healthcare providers nearby so that they can take some action. Machine learning, along with computer vision, also plays a crucial role in disease diagnosis from medical images. So if you see X-rays and all today, a lot of machine learning algorithms are being used there, along with image processing or computer vision, to identify presence of cancer, other diseases in the lungs and other areas of the body. Now let's take a look at some of the most commonly used tools for machine learning. The algorithms that are related to different machine learning tasks are known to all, and they can be implemented using any language or platform. So because they are all algorithms, you could use practically any programming language that you know to program those things and use them. You could implement using Java, C or C++ or .NET. But there are certain languages and tools which have been developed with a focus for implementing machine learning. So although you can use any kind of tool or technology, there are certain tools or technologies which are specifically built to be used with machine learning. So we are going to take a look at such tools and technologies. The number one is Python. which is one of the most popular open source programming languages widely adopted by the machine learning community. And it was designed by Guido van Rossum and was first released in 1991. Okay. And the reference implementation of Python, which is called CPython, is managed by Python Software Foundation, which is a nonprofit organization. It has very strong libraries for advanced mathematical functionalities. Some of those libraries are NumPy, SciPy, Matplotlib, scikit-learn, okay, and some of these, there's also Seaborn. We are going to see all these libraries when we start implementing some algorithms. Built on these libraries, there is a machine learning library called scikit-learn, which has various classification, regression, clustering algorithms embedded into it. So nowadays, it's very easy to perform linear regression or classification, by writing just a couple of lines of code. You don't even have to understand regression to perform it because it's so easy with Python nowadays. All the functions are all available and you can just apply them. Even if you own just a very small business, they could help you. The next language is R, which is a language for statistical computing and data analysis. It is an open source language, extremely popular in the academic community, okay, especially among statisticians and data miners. It is considered as a variant of S, which was a GNU project developed by Bell Laboratories. Currently, it is supported by the R Foundation for Statistical Computing. R is a very simple programming language. It has a huge set of libraries available for different stages of machine learning. And some of the libraries that are very popular are Blur or Dipler for data transformation, Caret for classification and regression training, RJava, which is used to facilitate integration with Java, TM, which is used for text mining, ggplot2 for data visualization. So these are some of the most commonly used libraries in R. And other than these, there are also packages like Shiny and R Markdown that have been developed around R to develop interactive web applications, documents, and dashboards using R, and you don't even have to make much effort to do it. The next language is MATLAB. So MATLAB is also known as Matrix. It stands for Matrix Laboratory. Is a licensed commercial software with a robust support for a wide range of numerical computing. And it has a huge user base across industry and academia. MATLAB is developed by MathWorks, which is a company which was founded in 1984. And it is a proprietary software. Okay, so it's more professionally built and rigorously tested and has comprehensive documentation. So unlike R and Python, which are open source and built by, just about anybody, I mean, not anybody, but a lot of people have contributed to building it. Whereas MATLAB is proprietary, which means it has been built by some company, and people are not just anyone can contribute to building it. And so that's why it is professionally tested. So it is much more reliable. It also provides extensive support of statistical functions and has a huge number of machine learning algorithms inbuilt. So that's why this is the kind of library that is still being used, not just by computer engineers, but by civil engineers and mechanical engineers as well. It also has the ability to scale up for large data sets by parallel processing on clusters and cloud. Next, we have SAS, which was earlier known as the Statistical Analysis System, which is another licensed commercial software just like MATLAB, which provides strong support for machine learning functionalities. It was developed in C by SAS Institute, and it was released in the year 1976. It is a software suite comprising different components. Okay, the basic data management functionalities are embedded in the base SAS component, whereas the other components like SAS/Insight, Enterprise Miner, SAS/Stat, etc., they all help in specialized functions in data mining, and statistical analysis. Next one is SPSS, which is owned by IBM, originally called Statistical Package for the Social Sciences, which is another popular package supporting specialized data mining and statistical analysis. It was originally popular for statistical analysis in social science, okay, which is why it is called SPSS. But nowadays it's popular in other fields as well. The last one I'm going to talk about is Julia, which was released in 2012. So it's pretty recent compared to all the other languages we just saw. It is an open source, liberal license programming language for numerical analysis and computational science. And it has baked in all good things of MATLAB, Python, R, and other programming languages used for machine learning, for which it is gaining steady attention from machine learning development community. So although it is much recent, it is gaining a lot of attention because it does have a lot of features combined from MATLAB, Python, and R. And another big point in favor of Julia is its ability to implement high-performance machine learning algorithms. So this is where I'm going to end this video, but I'll be back with the next one. So I'll see you there, and thank you for watching.